And so I have two scenarios that I'll show you in the, within this demo that we'll walk through. So the first one is what we call short-lived, and it is a simple scenario. Okay, so in this scenario, we're calling it short-lived environments. What the scenario itself is customer already uses automation in their environment for VMware, but doesn't automate the infrastructure. And what our goal here is to show you how simple it is to integrate. It doesn't take a lot of work from that northbound API, the PowerOne API, to be able to achieve the outcomes we were talking about before of being able to have a vSphere cluster that's ready to have VMs deployed on it. Okay, and so we'll take you through this. This will take us through the process of creates and deletes. Okay, this is all one Python script, but obviously the customer could use whatever configuration management tool they want to use to be able to do this. Okay, and then there's the three above the line here. There's really three API calls that are going to make this happen. And the first one I want to talk about a little bit is called the Select Assets API call. This is the PowerOne system assisting you with the placement of the server blades, all right, and the storage selection. Okay. This is not required. You can select use your own mechanism to select blades. You do not have to use this, but it just simplifies the overall process, and I'll show you here in a minute. Okay, and it takes your requirements along with some internal placement algorithms. Once we have that, then we can go ahead and just tell the system to build a CRG, right? And then all we have to do is track that job when it finishes. Okay. So the next stage here is this is basically written, it looks a little bit like YAML, though it's not, of some of the requirements that you would need to provide to the select assets algorithm here. So we talk about number of cores, the amount of memory, the amount of total storage you want within that CRG, and also a couple features of storage, right? And this is encryption and deduplication. Okay, so the script allows us to make some changes here if we want, or we can just accept what I have here. So in this case, we'll just change the cores to 60. We'll leave the memory at 100, and we'll leave the storage at 4. Okay, so there are new requirements here. Right, our 60 cores and 100 gigs of RAM, 4 terabytes of storage. What we're going to do is we're going to wrap this up as a JSON object, and we're going to post it. It's going to be a post operation to this endpoint. Okay. When you do that, what PowerOne comes back with is a bunch of proposals. Okay. So it actually came back, and I've just reformatted these so they're easy to look back. But it comes back as a JSON object from the select assets call. And in this case, it tells us here, you told us this was your requirements. Here's what I can meet it with. Here's the type of blades. So we have both a mix of 740s and 840s down here. We have, based on your requirements, it's going to take me this many servers to meet those. And then also, there's some additional available servers here if you want to expand past that. Okay? So again, this is just some proposals, and then we can use this information to actually build out the cluster. Okay, so let's just choose A. We'll choose the first one. And what we're going to be able to do is take that information, and we're just going to have to add the platform type, and we'll be able to build the JSON object that we need to send to PowerOne. Right, so this will be a post operation. We'll send this JSON object here to PowerOne to create the cluster. It will start a job, and you'll get a job ID back. Okay. So once we run this, we have our job ID. We're monitoring the status of the job, right? So we're using this get to monitor the status of the job. And then when it's complete, we'll have our outcome.
I can't stress the complexity in most organizations about even finding, do we have enough servers? Do we have enough storage to run? Let alone actually propose which ones it is. And this is all done entirely through software. Yep. And if this is connected to the back end of a provisioning system internally, a change control system internally, I can do this stuff dynamically in real time just by proposing what assets are available in the infrastructure. Just that first step can take days, in some cases weeks, depending on the operational procedures in an organization.
So at this point, we have created the CRG. We'll just take a look at the GUI real quick, just so that we can see it there. There's our new CRG we created, test 1. And we've gotten to the point, our outcome now is we have that cluster, and the next thing we're going to do is connect to the vCenter production, the production vCenter or workload vCenter endpoint, and start deploying VMs, right? That was essentially, that was a propose me a configuration based on my requirements API call. That was build it, and that was monitor it so I could tell when you're done with it. And now you're at the point of deploying virtual machines.
So is there ways, and is this what you're hoping to get from the developer community, are there ways to automate the creation of the virtual machines and then the container environments as well, once you have it all built, to start with the cluster build?
Absolutely.
Yeah. I mean, customers typically will have their own approach, that depending on the vertical. If you're running a VApp or you can deploy these templates. This is again, the demo masks a lot of this complexity to do with the back-end configuration of the SAN fabric. You know, again, if you just think, what does it take to install a vSphere cluster? You know, you need.
I didn't want to steal his thunder, but he's not going to do the demo. But imagine this with ServiceNow. You open up a service ticket that says, I need 24 cores. And then the IT person gets the request, and we've made an API call to say, these are the assets that are available to service this request. Would you like for us to proceed? And then ServiceNow can execute the post commands to provision that. And the only thing that the IT administrator did was, evaluate the right proposal of infrastructure and approve its execution. And they didn't have to do anything else. And we've had storage provision, we've had network deployed, and they've approved the ServiceNow ticket. So,
cool. So we've got our outcome now, and then let's say that we're done with this cluster, right? At some point, we're ready to remove it. Trey already told you we don't delete the storage volume, so I won't bother telling you that. But now to be able to get rid of the cluster and clean everything up, as Trey had said it, right? We're just, for my script right here, I'm just going to go out because I have a name, test 1. I need to find the cluster ID, right? So I'll go out and find an extra step to find the cluster ID here. And then I'm just going to issue a delete against that cluster ID. Right? Again, it goes out, initiates a job, the job runs. When the job's done, the cluster is gone. Okay? So again, except for the storage volumes.
But again, it's return the blade into the asset and inventory so it can now be used for other applications.
Exactly.
It's cleaned up the masking and the zone and everything on the SAN fabric all the way through up to beyond not deleting the actual storage on the array.
It's ready to be used for the next CRG you want to build.
And I can't tell you from a support perspective how many times that we find problems in infrastructure where things have been deleted and old configuration states have not been cleaned up. And so being able to tidy up in those configurations is a powerful thing for hygiene of infrastructure that you're running.
I think, again, I mentioned it, one of the important things is the automation obviously has huge value in terms of reducing that operational complexity, but it's not mandatory in the system. So it's available for customers running a PowerOne system to adopt it either holistically or piecemeal, depending on how their IT operations are, or they're mature enough to do it. I mean, Trey mentioned connecting it into a ServiceNow ticket. It could be some internal change control system, some internal provisioning system that already has people doing that work today. And this is about accelerating the IT transformation by not setting them this Herculean task to figure out how they automate these things. We've already put the thought process into giving them the universal screwdriver to help them do it.
So if you say you've got a couple of customers already. Have you got any of them as a reference case yet? Or?
The first installs actually go in next in 2 weeks, I believe.
What industry are they in?
What's that?
Are they like public sector? What's their?
The first customer, I obviously can't give the name, but it is running SAP HANA and a nuclear energy plant. So.
Yeah.
So it's a pretty mission critical use case, right?
What are they trying to solve with it? So are they going to do anything beyond, making it easier to have the environment the same way in the timer they're actually going to use.
So a lot of,
interesting
hey,
things
we're
on
back, we're live. So in this particular case, and this is true in many organizations like that, there are new regulations being imposed to update and upgrade systems to a certain result. And as they evaluated what they needed to build in SAP HANA, how they wanted to virtualize it, and the level of skill that they wanted to acquire to build out that environment, and the time frame that they had to do it, and the risk related to it, they were like, we're just going to have PowerOne do it. So that was that. It's right in our sweet spot of use case. I'll be honest. We are very honest with customers. If they like building their environments and they don't want to leverage automation, this is not the right product for them to buy. If you do want to get the benefit of what this technology is designed, then it's an excellent technology to invest in. But we're not out trying to convert everybody to PowerOne, only the people that would benefit from the underlying technologies.
I think you said it there, risk. The risk adverse are the ones that don't have the skill set maybe to pull it all together in the time frame.
Or the time. They may have plenty of skill set, but just no time to do it.
Yeah.
It almost gives you a kickstart into, like if you haven't been able to do all the modernization things, it kickstarts you and puts you on that new level.
Okay. So final demo here. So we have an existing CRG, right, our production CRG that we want to be able to expand and contract. Okay. So in this simple scenario, we have a customer that doesn't use a lot of automation in their system, but they periodically, seasonally, need to be able to take non-critical resources and put them into critical environments to handle the demand, right? So pretty simplistic scenario here, but what we want to be able to show is how easy it is to be able to expand and contract CRGs to handle that workload through a few API calls. Okay. So the first thing we want to do is we want to be able to go off and just collect the information about that environment, right? So I ran a couple gets here. One to take the cluster name and convert it to the ID. One to use the ID to collect the details. I got this big JSON object back. I can figure out now what's actually in my current environment, and I can use that to feed my requirements. So next page here, we see that our requirements, right, are based off what is actually configured currently. I have 84 cores, 384 gigs of RAM, and I have 4 terabytes. So let's say I want to expand that. So I have a new core requirement. Let's say I want 120 cores. I can leave the memory where it is, and let's say I want 6 terabytes of storage. Okay, so here's my new requirements that I've come up with: 120, 384, and then 6. And then I'm going to do the same thing. I'm going to post this to select access. Now, this is posting to select assets, not for a brand new cluster, but for an existing cluster. So it's going to look at what's already there and say, how much do I need to add? Okay. So it comes back with a single proposal here. And it basically says, here's your existing 3 servers. I'm adding 2 more to it to meet your core requirements. You didn't have any additional memory requirements. You just had core requirements. So we're going to add 2 more. There's also 3 additional servers there. And I'm going to increase your I recommend you increase your storage to 6 terabytes based on your requirements. So I'm going to choose this. Okay. So now I'm able to take that information and build my new JSON object that's going to be posted to my, patch to this URL, to that cluster, and that will modify the CRG. Okay, and again, this will start a job. And what we have our job ID here, right? We're going to monitor that to see when it's complete.
Could be handy in the previous screens to actually detail a bit more about what they have. So when they're wanting to think to go to 6, you already have 4 or whatever. Because at the moment you've got 3 groups there, but when you've maybe got 50, 60, it could be hard to track what's where and what is free. So yeah.
Part of the selection algorithm is proximity, but distribution across racks, because you want the algorithm to not isolate clusters into individual racks and experience power issues. So because we control the PDUs in the system, we do PDU switching, we understand all the electrical environmentals of the system as well. Part of our algorithm is distribution, so that if you have outages in racks, you're not impacted by them?
So with minimal automation, we're able to expand that to 5 servers to meet our new requirements. Okay. So again, and then you add the servers in there. DRS will take care of rebalancing the workload, and you've expanded your environment to handle the higher demands. So next. All right. So when we're done with that, we can go off and we can shrink it. We'll shrink it back down, right? Because modify cluster is not just expand; it is allow you to contract. Okay. So in this case, we go through the exact same process, but in this case, we're going to reduce. Right? We collect the information about the existing CRG. We display this here as our requirements, which is 140 cores and 640 gigs of memory and 6 terabytes of storage. Now, if I want to reduce this and contract it to my original level, I'm going to have to change all of these, right? So I'm going to go 84 cores. Oops. I'm going to go 384.
I'll warn you if you try to go too small, like if you set it at 10 cores and it's already using 50 of them or something.
Say that one more time.
So if you try to shrink it too far,
Yep.
warn you and stop it at some point.
Yeah, so what would happen if you went down, so these are your minimum requirements, it won't let you go below 3 servers.
Okay, yeah.
So even if I put this at 10, I went real low, it still would end up back at the original place. I don't have to be exact here. Okay. And 4 of the storage, so I have my new requirements, 84, 384, and 4. Okay. That's going to get posted to my select assets. And it's come back and say, here's the proposed servers, right? I'm going to go back to your original 3. Okay. Now to do this, we're going to have to evacuate VMs and put things in maintenance mode to be able to take these out, right? So that's all going to be done behind the scenes. Okay. So I took those requirements and built the JSON that's necessary to post to or patch to that endpoint. And then I get my job here, and then I can simply monitor my job. So again, these are very few. It's an API call to collect the data so you have the current information. And then it's an API call to go to select assets and let it decide where things should be within the cluster. Now you can do it yourself, right? You can pull back the servers, find out which ones are not in CRGs, and build out your own algorithms for that. But it's already in the select assets.
What status are those servers in now? Are they bare metal? Are they sitting?
Bare metal. They are sitting bare metal. Yep.
They're back to erase configs
Yep.
with no server
Yep.
templates applied.
I wasn't sure if you kept like a version of ESX on there to spin it up faster or anything like that at a later date.
We've talked about that as a requirement. Right now, we just delete the image right now.
Yeah.
But yeah, that's an interesting.
I suppose for people that are maybe short term, that could be handy if they're going to be up and down.
Yeah.
But in that long term example,
What we thought about there is what happens if they want to spin up a server with a different version of ESXi? You know, do you then insert the step of delete and install? You know, so anyway, maybe it's a fast lane to a particular version. You know, that we categorize in the API or something like that.
Just curious, the first customer for PowerOne, is it a virtualized HANA or is it going to be bare metal?
Virtualized.
Oh.
Good question.
And we can see now that our cluster's been reduced, right? So the purpose of this demo was just to simply be able to show you how easily it doesn't take very many API calls to achieve an outcome within PowerOne. Okay. Anything to add? I think we're.
And I just, to pull this full circle and say thank you guys. The real intent of the technology is to, again, codify our integration best practices, extend those best practices so they can be executed in any customer's automation framework, leveraging the infrastructure, assets that we've built into this product. And the feedback has been wonderful from the customers that have explored this. The pipeline for further exploration is keeping us all up around the clock. So I'm excited to talk to you guys the next time about how far we've come and what customers have implemented, and see, you know, the journey and how this expands. But hope you guys enjoyed the presentation.